Now, absolute value equations require two cases, and here's why. An absolute value is a distance from something. So I can go to the left to get that distance, or I can go to the right on a number line. And so because of that, we get this, I can go either direction sort of thing. So you get a positive version and a negative. The way that I want to think about it is this. Let's just say we have the absolute value of x minus a equals b. Now, I'm just putting just a generic so we can have it as a resource. The two cases that I'm talking about, I think of it as the positive case and the negative case. Because for absolute values, it is a directional thing. It is, I can get there so many units to the left or so many units to the right, so I can go either direction. If the inside is positive, the absolute value doesn't do anything to it, right? If we stick a positive 2 into an absolute value, it stays a positive 2. So if the x minus a is a positive thing, the absolute values are inconsequential. They don't do anything. So just take the absolute value off. And you just solve it. What is x minus a equals b? But now let's think what happens if we put a negative number into an absolute value. If I put negative 2 into an absolute value, it becomes positive 2. It becomes the opposite, okay? So what we have to do if a negative number is in there is we have to take the opposite of what's inside. So that's why we end up getting two different things. Now you'll notice that the absolute value is isolated, meaning it was absolute value equals a number. So that's, you only set up the case, the two cases, when it's absolute value equals a number. If just like in a square root equation or that fractional exponent equation, we have to get that thing by itself. So let's start with the first one here that they've given us. The absolute value plus 5 equals 5. Now, the first thing we have to do is move that 5, just like if that was a square root. So that's kind of why these things are lumped together. You have to isolate that thing. So this would be the absolute value equals 0. Well, let's think about a positive case and a negative case for this one. The positive case gives you 0. The negative case gives you 0, because if I divide by -1, I still get 0. 0 divided by anything is still 0. So there is only one solution to this one, and that is that v equals 0. Okay? So, and that only happens if you get a 0 for your answer. But you'll notice I didn't recognize that until I have moved that over. So you always isolate whether it's a square root, whether it's a fractional exponent, or whether it's an absolute value. So now let's look at one that has a little more math to it. So the absolute value is by itself. It is equal to a positive number, so that tells us we need to proceed. Because an absolute value is a distance, it should always equal a positive number, just like a square root should always equal a positive number. Okay, so the first thing we want to do is case 1. I'm going to call that the positive case. And the positive case is that 6w minus 15 is already a positive number, so I can just keep it the way it is and set it equal to 3. Now the negative case, I'll call case 2. Case 2, I have to make it the opposite of what it was before I'm going to get 3. Okay. Now that second case can also be written in a different way. If I divide the negative to the other side, it's also where 6w minus 15 was a -3, because the absolute value of -3 is also equal to 3. So there's two different ways to think about it. Okay, now let's solve our case 1. Let's solve case 1. For case 1, it's just a simple multi-step equation. Add 15 to both sides, divide by 6. So our first case is 3. Our second case, if I add 15 to both sides, this time I get 12 because a positive 15 and a negative 3 makes 12. And then when I divide by 6, I get 2. Now, just like our absolute value does require just to take a second to check your work, because you can sometimes get these funky possible solutions, those erroneous solutions. So just check it. If I plug in 3 right here, I get 18 minus 15, which is 3, and the absolute value, that's 3. So that one's good. So let's circle that one. That one works really good. So that one worked. Now let's plug in 2. 6 minus 2 is 12. No, 6 times 2 is 12. Minus 15 is negative 3, but the absolute value of that is 3. So that one works too. Okay. So as long as you isolate and it says absolute value equals everything else, absolute value equals everything else, then the number should work out okay. Does anybody have any questions about that absolute value equation type 2? Everybody see how I got that? Okay, now let's look at our next type. For the next type, see this has that negative 32 hanging out there? We've seen absolute values like that. That absolute value needs to be by itself. So before we make any judgment calls, we need to move that 32. So we're subtracting. So the opposite of that is you got to add, right? And so let's, before we do anything, before we set up our 2 cases, let's add 32 to both sides. So we get the absolute value of u plus 3 equals 17. Okay. Now, only when the absolute value is completely isolated, absolute value equals everything else, do we set up our 2 cases. Okay. So case 1, the positive case. Case 1 is just where u plus 3 equals 17. Just take off your absolute values. The negative case, case 2. You can write it as u plus 3 equals negative 17, or the opposite of u plus 3 equals 17. It doesn't matter. I like to just go u plus 3 equals negative 17. Why? Because the absolute value of negative 17 equals 17. And I usually will do that if it's equal to a number. Sometimes we'll get some that have u's on both sides. Okay, so now it's just 2 very simple equations, right? If we subtract 3 from both sides here, we get u equals 14. If we subtract 3 from both sides here, we get u equals negative 20. Now, it is a very good idea to always plug back into your original, because then you'll check any sort of mistakes you may have made. Okay, so let's plug in 14 back into the original, exactly the way it looked. Okay, so if I plug in 14 here, I get the absolute value of 17, which is 17. Take off 32 is negative 15. Bam, that one works. So let's go ahead and circle that one. That one works. That's great. Now let's check negative 20. Negative 20 minus 13, you have to get that answer, which is negative 17. Now an absolute value makes that a positive. So that's positive 17. 17 minus 32 is indeed negative 15. It works. Circle. But just always take a minute. Check it in the original. Did it work in my original? So if it doesn't work in the original, then you're going to have some issues, okay? Okay. Now, the last type is this type 4. You'll notice we've got a 5 on the outside. We've got a 30 We have some stuff going on here. So the first thing I would do is isolate your absolute value, just like we've talked about before. So this plus 30 here, let's subtract 30 from both sides. So we get 5 times the absolute value of y minus 6. If we subtract 30 from both sides, we get equals 0. So it actually becomes very similar to our very first problem. Now, the 5 can be handled a few different ways. If the 5 is a negative, you don't want that. I would multiply both sides by -1. Okay. If the 5 is a positive like this is, we can just bring it inside our absolute value. Only if the 5 is a positive, we can distribute it into our absolute value. Okay? Okay. So now that we've done that, we don't necessarily need a positive case and a negative case here. Won't it both equal 0 no matter what? So only when it's equal to 0 do we get 5 times the quantity of y minus 6 equals 0. Well, that's 5y minus 30 equals 0. 5y equals 30. Y equals 6. So you're only ever going to get one answer if the absolute value equals 0. So that's not going to happen too often, but it could happen. Okay. If you check it back in your original, 6 minus 6 is 0, times 5 is still 0, plus 30 is 30 indeed. So it works just fine. It's awesome. Now, on your homework, there are only 2 absolute values, but I need you to add 2 more. There's a few different cases, so I want you to explore some different cases here. I'm looking. Okay, so there's going to be 4 of them. So remember, you were going to get the absolute value by itself. Let me write that last one so it looks a little nice. So that says the absolute value of 1 minus 4x, take away 1 equals 5. Okay. Okay, so you're going to get the absolute value by itself. Once you have it by itself, as long as it's equal to a positive number, set up your 2 cases. If it equals a negative number, you know it's not going to work. But if you forget that, when you go to check it, you'll see it doesn't work. You'll end up getting like a positive equals a negative. So you have the rest of class to work on these 4, work on any of the ones that you had from the beginning of 2-6. Tomorrow we are going to talk about 2-7. Tomorrow is inequalities, so we'll talk about that tomorrow. So you have time now to work on those problems. If you need any help, just ask.